Okay, so we're continuing our first session of the pre-Leaving Cert Algebra revision course. The last video we looked at simplifying expressions, and there was some multiplication of brackets in that video. This lesson we're going to look a little bit more at expanding brackets, in particular when we have brackets multiplied by other brackets, so brackets upon brackets, let's say. As in the last video, we are going to base the lesson around 10 key examples. Each one slightly more difficult than the previous one, or each one bringing something different than seen previously. And that way we get to see kind of 10 different types of brackets upon brackets questions, even though the idea behind each of them is pretty much the same. If those questions are quite easy, and what I would do to decide if they're quite easy is go and have a go at the questions. Again, you're ticking them off on your checklist, working your way down. When you're finding a question that you find difficult, perhaps the last two, you're going to then look in the vast bank of questions that's also attached to this lesson to find similar questions to see, could you improve your skills in those. If you're happy with these 10 key examples and you'd like to try something harder, or you'd like to see where it links to the Leaving Cert, we have modified 7 Leaving Cert higher level questions to show where the multiplication of brackets occurs within those questions. So all of the 7 questions have been slightly modified so that we can just concentrate on the multiplying brackets aspect of it, rather than looking at topics that we won't have covered until we're actually in 5th year higher level maths, or indeed 5th year ordinary level maths. Finally, if we're happy kind of with all those and we'd like some extra practice questions, or if you found the initial 10 questions, the key examples, difficult and wanted more practice of those, the vast bank of past paper questions and work solutions are attached, and you can obviously go and have a go at some of those. As before, if you have any questions, make sure to ask. Occasionally, sometimes you might see a typo in the question, and don't doubt yourself if you've kind of done something and it's different than a solution that I have. It could be that I have made a mistake, or maybe you just need some small clarification on what you're doing to fix it. And don't be afraid to either drop me a mail or just comment beside the video on YouTube or in the Dropbox. Okay, so moving on, we're going to look at the 10 basic examples. And the key with these ones is, and again we can see that we have the syllabus up here from the Leaving Cert, which basically shows what these questions look like. We have a bracket with some terms inside the bracket, and it's multiplied by another bracket that has a couple of terms in that bracket. And so our first example very much looks like this, where we want to multiply x plus 9 by 2x minus 1. Now, depending on your skill level, if you're a very good junior cert higher level student, or if you are in Leaving Cert higher level and you're kind of happy with taking shortcuts, I would do the following with this, and then we'll go and we'll show the method that we'll continue with for the rest of this lesson, which kind of just makes sure that you don't make any mistakes. But what I would do with these was, the key is that every part of the first bracket needs to be multiplied by every part of the second bracket. So we need to multiply x by 2x and x by minus 1, and then we need to multiply 9 by 2x and 9 by minus 1. And if I was doing this question, I would probably do it this way. If you're, like I said, in Leaving Cert Honours Maths, probably very good at multiplying out brackets, I would probably do this as well. So x by 2x, first of all, is 2x squared. X by minus 1 is minus 1x. Then we do 9 by 2x, and 9 by 2x is 18x. And then we do 9 by minus 1, and that's minus 9. So again, everything in the first bracket was multiplied by everything in the second bracket. As in the last video, we can now simplify some of the terms. So 2x squared has no like terms. It won't combine with any of the other terms in the question. So we'll write down 2x squared. Minus x and 18x are like terms. So 18x minus 1x is plus 17x. And then obviously minus 9 is a constant, and there's no like terms in the question, so it's minus 9. One thing I suppose I forgot to emphasize the last day, just as I'm looking at it here, if we see an x by itself and no number in front of it, just be aware that that's minus 1x. And sometimes it can be helpful for people then when doing their sum and comparing like terms to say plus 18x minus 1x. A lot of people, when they see the minus x, they're a little bit unsure what to do with that. And so if you have an x on its own, that's a solitary x, so it's a 1x. And we don't write down 1x, we're happy enough just to write down x, but just know that there is a 1 in front of that. Now, that's the kind of quick method, and if you're kind of looking at, just really quickly brushing up on your skills, you might decide with the 10 examples just to do them exactly like that, and you may be comfortable with that method. The method that we're going to look at, though, is called opening the brackets. So, opening the brackets, and it's probably the method that most people learned when they did this kind of question originally, and like I said, I think it's a good way to do it because it ensures you don't forget any terms, particularly if there's more than 2 terms in each bracket. But like that, it's a personal preference, I suppose. So let's have a look at how we open the brackets. We wanted to multiply the x by the 2x and the minus 1, those green arrows there. And so what we do is we write down x, and we're going to multiply that by 2x minus 1. And then the blue arrows, well, they wanted to multiply 9 by both the 2x and the minus 1. Now, the term opening the brackets comes from we've opened up the first bracket. So it's in a bracket, x plus 9, and we've split it up into x and plus 9. And a lot of people, when they're doing this sum, if I just write it over here, the first thing they do is they just open the brackets. They write x plus 9 opened up like that. And then you multiply the x and the 9 by the other bracket. So 2x minus 1 by 2x minus 1. So, if you get good at them, obviously you don't need to open them up like that all the time. You can just say x on 2x minus 1 plus 9 on 2x minus 1. Okay, so multiplying this out, we have x by 2x is 2x squared, x times minus 1 is minus x, 9 by 2x is 18x, and 9 times minus 1 is minus 9. Now note, that's exactly what we had the previous time when we sort of took a shortcut and just watched what the arrows were doing rather than opening up the brackets. Tidying up like terms again, it's the minus x and the 18x, so 18x minus 1x is 17x, and then finally the constant minus 9 at the end. So I went a little bit more slowly through that one than I will go through the rest of the sums, but just to explain the different methods of doing it by the arrows method, where you're kind of working it out in your head, or multiplying each term in the first bracket by each term in the second bracket, or if you actually do the process of opening up the brackets to ensure that you don't forget any of the terms. Okay, so that's example 1. Let's move on to example 2. Example 2 basically is the same, except that we have 3 terms now in the second bracket. So I'm going to open up the brackets. So again, what's opening up the brackets? I'm going to write the x here, and then I'm going to leave some space for this bracket here, and I'm going to go down and write the minus 2. So I've opened up the bracket. Then I'm going to multiply each of the x and the minus 2 by the second bracket, x squared minus 3x plus 11, and then minus 2 on x squared minus 3x plus 11. So I'm going to multiply all this out. So x by x squared is x cubed. Remember that the x has a power of 1, and the x squared obviously has a power of 2, and the rule when we're multiplying the same letter or same variable is we add the powers. So 1 and 2 is 3. And multiplying x by minus 3x, we get minus 3x squared, and multiplying x by 11, we get 11x. Minus 2 by x squared is minus 2x squared. Minus 2 by minus 3x, remember a minus by a minus is a plus, so plus 6x. And then minus 2 by 11 is minus 22. So we've 6 terms here. We can see if there's anything that simplifies. There's nothing that goes with the x cubed, so we're just going to write that down. Common terms then, minus 3x squared is a like term with minus 2x squared, so minus 3x squared minus 2x squared is minus 5x squared. Again, we're thinking of a number line or temperature. What's minus 3 minus another 2? Minus 3 minus 2 is minus 5. 11x plus 6x is 17x, and then we have the minus 22 at the end. I won't do this for every sum, but just to kind of show the quick method again, just for people who might like to learn that and not be opening the brackets all the time. So what I would do is I would say to myself, I'm going to multiply everything in the first bracket by everything in the second bracket. So I'm going to multiply the x by the x squared, by the 3x, and by the 11. So x by x squared is x cubed. X by 3x is minus 3x squared. X by 11 is 11x. Then I'm going to multiply the minus 2 by everything in the second bracket. So by the x squared, by the 3x, and by the 11. So minus 2 by x squared is minus 2x squared. Minus 2 by minus 3x is plus 6x. Minus 2 times plus 11 is minus 22. And again, you can see that we ended up with the second line of the first example. So you do get the same answer, it's just a different approach. Again, why might we decide to open the brackets? It sort of ensures that we don't forget anything. Sometimes when we're multiplying each thing in the first bracket by the second bracket, we can forget terms or get mixed up as to what work we've done already. And so opening the brackets ensures that we don't make that mistake. Okay, so the finish of this, just to kind of complete it again, x cubed goes by itself. Minus 3 minus 2 is minus 5x squared. 11 and 6 is 17x, and then we have the 22. So the same answer, whatever way you do it. Example 3 is very similar to example 2, just that don't always expect the x squared to come at the start of a bracket. It won't make any difference to the sum. We're going to do it in the same manner. We're going to open up the first bracket, so it's going to be 2x on 4 minus 5x plus x squared, and then minus 3 on 4 minus 5x plus x squared. And remember, splitting up the 2x and the minus 3 in the first bracket, that's the opening of the bracket, and each of those terms gets multiplied by the second bracket. Multiplying this out, we get 2x by 4 is 8x, 2x times minus 5x is minus 10x squared, 2x by x squared is 2x cubed, minus 3 by 4 is minus 12, minus 3 by minus 5x is plus 15x, don't forget a minus by minus is a plus, and then minus 3 by x squared is minus 3x squared. So we have a look across the sum, and in the last example our cubes were at the start just because of the way the second bracket had been lined out. So as I said before, don't be afraid if the order isn't as you've seen it in other sums, the multiplication is still the same. We do like to start an expression with the highest powers, and the highest power in this question is x cubed, so we write down 2x cubed. It's not wrong if we don't start with that, but you know, it's a good idea to always do it in that way, because someone could be correcting an exam of yours and they might see that it doesn't start with a 2x cubed and quickly mark it wrong, and not take the time to go through what might be a valid answer that you've written down. So you kind of want to do the correct process each time. We have minus 10x squared and minus 3x squared. They're like terms, so they go together. Minus 10 minus 3 is minus 13x squared. We have 15x and 8x, which is 23x. And then the only constant in the question is the minus 12, and that goes at the end. And as we can see, we're left with 4 terms, and none of these are like terms. As we said in the previous video, x cubes and x squareds cannot be joined together through addition or subtraction. And so they're not like terms, they can't join together, even though they have the same letter. Okay, example 4 is where we have a bracket squared. And so how does this relate to the previous examples? Well, if you think of a bracket squared, when you square something, you're basically just multiplying it by itself. So x plus 4 squared is x plus 4 times another x plus 4. Now it looks like the previous 3 examples, and what we're going to do is we're going to open the first bracket, so we have an x on x plus 4 plus 4 on x plus 4. Multiplying this out, we get x by x is x squared, x by 4 is 4x, 4 by x is 4x, and 4 by 4 is 16. Finally, we have a look to see if there's any like terms in the question that can be combined, and we can see that the two 4x's in the middle, they can be combined to give us 8x. 4x and 4x is 8x plus 16. When we square a bracket, there is a shortcut. Again, it might be something that you've seen in Junior Cert, and certainly something that you'll be shown in the Leaving Cert. Oh, that's not particularly straight. Let's try again. And it's a quick way to square out a bracket. And what we do is we take what we're trying to square out. So x plus 4 squared has 2 terms in it. And what we do is we square the first term in the bracket. So x squared is x squared. We square the last term in the bracket. So that's plus 4 squared is plus 16. 4 squared is plus 16. And we write that at the end of the sum. And then what we do is we multiply the 2 terms, and we times that by 2. So x times 4 is 4x, times 2 is 8x. And we can see how quickly then, from learning this method, we can get to the same answer as we got before. So I'll show you another example of that, and we'll take a minus this time. Let's do x minus 3 squared. So what we're going to do is we're going to square the first, that's x squared. We're going to square minus 3. Minus 3 times minus 3 is plus 9. When you square a negative number, you always get a positive number. And then we're going to multiply the 2. We get minus 3x. And then double that, or times it by 2, which is minus 6x. So in words, what's the rule? Well, we square the first, we square the last, and it's twice the product. Twice the product. Product means when you multiply two numbers together, so twice the product. So square the first, square the last, and twice the product. So just a quick way to kind of square out a bracket rather than having to open it up and do this all the time. Especially, like I said, if you're doing Leaving Cert higher level maths and you're looking to do a sum quite quickly, although you're trying to be careful obviously at the same time. Example 5 is a nice example where it takes the x plus 4 squared that we already had, and then we're going to subtract an x minus 4 squared from that. Now, the key with this question is we need to subtract all of this x minus 4 squared. And so when we write it down, it's going to look like this. So the x plus 4 squared is obviously x plus 4 times another x plus 4. Then we have a minus sign, and we want to do x minus 4 times x minus 4. Now, if we continue the sum just like this, we'll make a big mistake, because what will happen is we'll multiply out these two brackets here, and then we'll only apply that minus to the first term that we get. And so what we want to do is we just want to put a bigger bracket. Sometimes we put a square bracket, but it doesn't matter if it's round, around those second two, just to say that when we tidy all that up, we're going to subtract all of the terms in that red bracket and not just the first part of that bracket. Okay, so what I'm going to do is I'm going to open this up as I did the last time. So it's x on x plus 4, plus 4 on x plus 4, and then minus, and again, I'm just going to put in this red bracket, make sure I pick the right shade of red, and I'm going to open up these two brackets, or the first bracket, let's say. So x on x minus 4, minus 4 on x minus 4, and then just close that with my red bracket again. So again, we'll see why this is important in a second. So multiplying all this out, we have x by x is x squared, plus 4x, plus 4x, plus 16, minus, and the red bracket. So x by x is x squared, x by minus 4 is minus 4x, minus 4 by x is minus 4x, and then minus 4 by minus 4 is plus 16. And we'll just close the bracket there, just to see what effect this red bracket has. So I'm going to remove the red bracket now. I could do a little bit of tidying up the 4x and the 4x and the minus 4x and the minus 4x, but I think I'll just leave that till the next line. So I'm just going to write down the first portion again as it was. And then, what's the importance of the red bracket? Well, if we didn't have that red bracket here, what I would do is I would have this minus, and then I would have this x squared. But the rest of the terms wouldn't be affected by this minus if I didn't have the red bracket. By putting the red bracket in it, I want to subtract all of those terms. So now applying the minus, as we saw in the last video, we have minus by x squared is minus x squared, minus by minus 4x is plus 4x, minus by minus 4x is plus 4x, and minus by plus 16 is minus 16. So finally, there's a little bit of tidying up we can do. We can simplify this expression now because there's lots of like terms. X squared and x squared are like terms, but we have an x squared minus an x squared, and that gives us 0, or they cancel. We have a 16 minus a 16, and they cancel. And so what we have left is 4x plus 4x plus 4x plus 4x, which is 16x. Now, how could we have made this question slightly shorter? Well, if you remember in the last example, we have a shortcut now to square out those brackets. And so you could have applied that method and probably saved yourself possibly 2 or 3 lines in this sum. So if you haven't had a go with the short method of squaring brackets, it's a good idea maybe to try that question again and see can you get down to the right answer of 16x. But again, the red brackets are very important in this, an outer bracket just so that we apply the minus to all the terms in that. Okay, example 6. Example 6 is just an example where we have 2 different variables. So this is the first example where we just have different letters in this example, and we'll see the effect that that has. We're still going to open the first bracket, so it's going to be 2a on 3a minus 4b, and then plus b on 3a minus 4b. So multiplying this out, so 2a by 3a minus 4a, 2a by 3a is 6a squared, and then 2a by minus 4b. Well, first of all, we multiply the numbers. 2 by 4, or 2 times minus 4 rather, is minus 8. And then what do we get if we multiply a by b? Well, if you multiply 2 letters together and they're different, we essentially just write them down beside each other. So AB beside each other means A multiplied by B, and they don't tidy up into something or anything smaller than that. So 2A times minus 4B is minus 8AB. Similarly, what's B times 3A? Well, B times 3A is 3AB. Now, you might say to me, well, could I have written it as B 3A? Technically, I suppose we could write it something like that, or we could have put a B and a 3A like this, or we could have 3BA. Why do we write it in alphabetical order, starting with the number and then the letters in alphabetical order? Well, so that we can see if it joins easily with other common factors. If we decide to write down BA, we might decide that it doesn't go with AB. So we always just write it down in alphabetical order. And remember, A times B is exactly the same as B times A, and so it doesn't matter the order you write it down in, better to write it in alphabetical order. Finally, B times minus 4B is minus 4B squared. Tidying like terms, the only like terms in this question are the ABs. So we have 6A squared at the start, and then minus 8 plus 3. Again, think in the number lines, if we had minus 8 plus 3, we would have minus 5AB, and then we have the minus 4B squared at the end. Okay, example 7. Example 7, again, we have two variables, and we just want to see the effect of having the same letters in both brackets, but different signs. So let's see what happens when we do a sum like this. So if I do x on x minus y plus y on x minus y. So I've opened up the first bracket and multiplied each term in the first by each of the terms in the second. X by x is x squared. X by minus y rather is minus xy. Y by x, again, you might be tempted to write down yx, and technically that's correct, but we like to keep it in alphabetical order. So we write down plus xy rather than yx. And then y by minus y is minus y squared. What we can see now is that the xy's actually end up cancelling. They are like terms, minus xy plus xy, but they both end up cancelling each other out and giving 0. And we end up with x squared minus y squared. When we move on to factorizing in a later video, we'll see that factorizing, this is called the difference of two squares, and if we were to factorize this, we get back to the top. So expanding brackets gets rid of the brackets, and then factorizing, which we'll see in a later video, puts it back into brackets. And I'm sure lots of people in the junior cert will have seen the difference of two squares where we separate the brackets and we have a plus and a minus with the same terms inside each bracket. Okay, the next one is our first question where we have 3 terms in the first bracket and 3 terms in the second bracket. So how do we open this up? Well, we're going to do it in the same fashion. We're going to multiply every term in the first bracket by every term in the second bracket. So we're going to multiply 2x by 3x minus 4y plus 3, then minus 3y by 3x minus 4y plus 3, and then plus 1 by 3x minus 4y plus 3. So when I open up the first bracket here, I actually have 3 terms to split up or spread out across the width of my sum. So, and then I put down the second bracket multiplied by each of those things. So minus 3y on 3x minus 4y plus 3, and then plus 1 on 3x minus 4y plus 3. The benefit of not splitting them up when you open the brackets at the start is that you won't end up with these big spaces because you're not really sure how much space to leave when you're writing them in. So I like writing them down. 2x on this, write down this bracket, then 3y, write down this bracket, and then 1, write down this bracket. Unless, of course, you're doing the shortcut. And again, with this question, the shortcut is a bit dangerous because you're going to end up with 9 terms here on the next line. And it would be very easy to forget them if you just tried to multiply everything in the first bracket by everything in the second bracket. Okay, multiplying all this out, we have 2x by 3x is 6x squared. 2x by minus 4y is minus 8xy. Again, we have 2 variables, x and y, and we go in alphabetical order, just writing them beside each other. 2x by 3 then is 6x. The second set of brackets, we have minus 3y by 3x, which is minus 9xy. Again, we're going with alphabetical order. Minus 3y by minus 4y is plus 12y squared. And then finally, minus 3y by 3 is minus 9y. And then getting to the last set of brackets, we have 1 by 3x is 3x. 1 by 4y is minus 4y, and then 1 by 3 is plus 3. So taking a quick look to see what like terms we have, there's nothing that goes with the 6x squared, so we write down 6x squared. The xy's, we have minus 8xy, and we have minus 9xy, and minus 8 minus 9 is minus 17xy. We then have 12y squared. There's nothing goes with the 12y squared. X's, we have 6x and 3x. They join together to give us 9x. And then the y's, we have minus 9y and minus 4y, which gives us minus 13y. And finally, the only constant in the question is plus 3. Now, in a question like this with so many variables and so many different types, nothing else is common in this last line. So there's no like terms in the last line, even though we have lots of x's and y's, they don't go together. There's no particular right order for this. Generally, again, we go alphabetical order. I've started with the 6x squared. But then because terms have mixes and matches of x and y's, it doesn't really matter the way you kind of finish that out. Okay, 2 examples left. So example 9, this is an example where we have surds. And so we're going to do a small bit of revision of surds and see what we remember. The process is the same. We're going to split the first bracket. We have 2p on p plus root q. And then we have plus root q on p plus root q. So looking at the rules of surds, or one or two of the rules of surds, one of the rules of surds is that if you have a surd, let's say root of a, for example, and we multiply it by another surd, let's say the root of b, we can put this all under one square root sign or one surd sign and multiply the two variables together, so the two numbers together. So a by b is ab. Let's say we had root 2 by root 3. We could say that that's root 2 times 3, 6. So that's a very important rule of surds. What happens if we multiply the same term by itself? Well, let's have a look at an example if we multiplied root 2 by root 2. So it's the same term, we're multiplying it by itself. Well, root 2 by root 2, the rule is to multiply the numbers, so that's root 4. And what's the root of 4? Well, the root of 4 is 2. So we can see that when we multiply a root or a surd by itself, we get the number under that surd. If we were to multiply root x by root x, that would be the root of x squared. And what's the root of x squared? X. So again, multiplying a surd by itself, we get the number or the term underneath that surd. So looking at our example, we've already split the brackets here. 2p times p is 2p squared. Now, what happens when we multiply 2p by root q? Well, they don't really go together, and because 2p isn't under a surd, we can't join them and make one surd out of them. So the only way we can write that is by actually writing them beside each other like this. 2p root q, and that's as tidy as we can get that. What's root q times p? Again, that's root qp, the two terms beside each other. But again, we want to go in alphabetical order, so we're going to say that that's p root q. And then finally, what's root q times root q? Well, if we have a look at what we found out over here, if you multiply a surd by itself, we get the number or the term underneath that surd. So root q times root q is just q. Okay, tidying all this up, can we spot if there's any like terms? Well, 2p squared doesn't go with anything else, and q definitely doesn't go with anything else. But we have p root q's. We have 2p root q here, and we have another 1p root q here. So writing down the 2p squared and then joining the 2p root q and the p root q, we get 3p root q. And then finally we have the q at the end. Now, I would agree that this is probably a little bit of a stretch in terms of material we might have seen at our junior cert. This question has been asked in our junior cert. There is a question in the question bank that you'll see that has C's and D's in it that's very similar to this question. And so it's very important that we know how to do something like this with the surds, even though granted it is a good bit more trickier than some of the questions we've seen before, and it does require us knowing some of the rules of surds. Okay, the last example then is just an example where we have a fraction within the bracket, and this again might not be something we'll have seen an awful lot in the past, but it's quite easy to do. We're just going to split up the first bracket, so 4x here, and then we'll put plus a half, the second term of the first bracket down here. And then we're going to multiply that by 2x minus 2, and then by another 2x minus 2. So I've opened up the first bracket. 4x times 2x, well, that's 8x squared. 4x times minus 2 is minus 8x. A half times 2x, well, a half times 2x, if you multiply a half by 2, you get 1. So that's just going to be 1x. And then what's a half times 2? Again, a half times 2 is just 1, so plus by a minus is minus 1. And then tidying this up, the only terms that go together are we have minus 8x plus x, and they give us minus 7x. So 8x squared minus 7x plus 1. So just an example of where we might have a fraction. A lot of the older questions you'll see in the question bank in the past papers have fractions in them, and certainly the next lesson we're going to look at on substitution has a lot of fractions. So to be comfortable multiplying out fractions is an important skill to have moving forward. Okay, that's the 10 key examples. I have one more. I like to keep it to around 10, but I've just put a star beside this one just so I could squeeze in an extra one. And that's what do we do if we have 3 terms multiplied by each other. There is an example in the harder leave insert questions similar to this, where I think we might have x plus 1 times x plus 3 times x plus 4, or something similar to this, where we multiply 3 brackets together. And so maybe by having a look at this example, we could then go and try this harder example. If you get a question like this where you have to multiply 3 terms together, we have to start by either multiplying the x into these 2 terms and then multiplying that by the second bracket, or what I prefer to do is whatever's out in front, I like to just leave that there until the end, and I'm going to put a square bracket. Again, I'll color it red so we can see the difference. And I'm going to multiply inside that square bracket first, and then only at the end of the sum will I join the x back into it. So keeping the red bracket in the question, I'm going to split up this first bracket here. So again, opening the bracket. So I have 2x on 4x minus 2 plus 3 on 4x minus 2. So I've just opened up the first bracket and multiplying it by the second. So again, I'm keeping the x outside until the very end of the sum, and then I can join it back in. Multiplying out the brackets inside of the red brackets, I have 2x by 4x is 8x squared, 2x by minus 2 is minus 4x, 3 by 4x is 12x, and 3 by minus 2 is minus 6. Okay, so again, we have the x outside. I don't need to write it as a red bracket anymore. I'm just going to have it as a black bracket because we've the inner brackets gone. So just tidying this up, I have the 8x squared here. Minus 4x plus 12x can be combined to give plus 8x, and then the minus 6. And I'll close that bracket. And then the very final thing I'm going to do in this question is multiply in this x. So that would be x by 8x squared is 8x cubed. X by 8x is 8x squared, and x by minus 6 is minus 6x. Now, what if that had been an x plus 1 at the front, like it is in the leave insert higher level question that you might try? Well, then we're going to have to open up the brackets again, and the sum becomes that little bit longer with maybe 3 or 4 more lines. So it's a good question to kind of finish on, and a good question maybe to go and practice to see can we progress what we've learned from our junior cert and bring it on a small bit further to a question like this at our leave insert where we're multiplying 3 brackets together. Okay, so the video is going to continue with the solutions to the trickier examples. So whether you want to go and try those first and then come back maybe and have a look at the video, or whether you've decided that those 10 questions were quite tricky and you'd like to go and practice those before maybe advancing and doing some of the trickier examples. So again, if you're practicing questions, the question bank is there with all the past junior cert, ordinary level, higher level, leave insert ordinary level questions, and they're good ones just to practice to get your basics up. So yeah, we'll spin over to the trickier questions now. Okay, so going to run through 7 trickier examples that have been adapted from leave insert higher level questions. Now the first question here that we're going to look at, this first example is actually word for word from the 2019 leave insert higher level paper, and then the rest of the questions have somehow been modified just to show the multiplying brackets aspect of the question. Indeed, with this first question, we're going to multiply the brackets, and I think the second part of it is a bit of a leap for maybe a junior cert student, but we'll have a go at it anyway. But again, as I always say with these trickier questions, don't get too disheartened if you get lost a little bit of the ways through this. We're really concentrating on whether we can multiply 2 brackets together. So we have 2x plus 1, and then we have x squared plus px plus 4. And the question says in the expansion of this, and so they want us to expand this. What does expand mean? Expand means multiply it out so that the brackets are gone. We're going to take the first bracket and we're going to open it up, so it's going to be 2x on x squared plus px plus 4, and then plus 1 on x squared plus px plus 4. Multiplying this out, we have 2x by x squared is 2x cubed. 2x by px, well, the x by the x will give me an x squared, and then I have the 2p in the term as well, so it's going to be 2px squared, and that's as neat as we can get, 2x times px. 2x by 4 is 8x, 1 by x squared is x squared, 1 by px is px, and 1 by 4 is 4. And if you've gotten that far, that's a star, put a star beside that. That's as far as we really need to go in this question. I will complete the question for those people who are interested, but really in terms of coming from junior cert, that would be probably enough. Though I think there is students who, coming from junior cert, could finish this question. They talk about the coefficient in the next part, and we said in the last video that it's important to learn what term, expression, coefficient, variable, constant, what all these words mean. Coefficient is the number in front of the variable. The only variable in this question is the x. The p is actually a natural number, it's just that we don't know what that number is. So 2 is a coefficient, 2p is a coefficient, 8 is a coefficient, 1 is a coefficient, p is a coefficient, and then 4 obviously is just a constant. This question says that the coefficient of x, now there's two x's here, I'm going to circle them like this, and so the coefficient of the x parts are 8 plus p. So there's 8x and there's another px, and so the coefficient is 8 plus p. The coefficient of x squared then is 2p, and we can't see the number in front of the x squared, but it's a 1, so 2p plus 1. And what does the question says? Or what does the question say? It says that the coefficient of x, the purple bit here, 8 plus p, is twice the coefficient of the x squared part. And they want us to find p. So here we have a simple linear equation. We're going to, revise equations coming up, but if you've got this far, I'm assuming that people can finish off an equation. So we have 8 plus p equals, multiplying this out, we have 4p plus 2. Collecting the p's on the right hand side, let's say we have 4p minus p, and then on the left we have 8 minus 2. 8 minus 2 is 6. 4p minus p is 3p, and so p is 2. Now, don't overly worry about that bit on the right hand side. Again, that's the second part of the question. More Leaving Cert Honours material. What we were concerned with was whether we could multiply out the brackets, and if we could, well then we could possibly go and attempt the second part of the question. The one thing for sure is, if we don't have the skills at multiplying out two brackets, there's no way that we can attempt the second part of the question, and that's the key here. So hopefully there was one or two people who were able to finish it out and maybe get the p equals 2, but again, don't overly concern yourself with that at the minute. Example 2 is an example from a Leaving Cert ordinary level paper. Now, albeit the old course a good few years ago, they tend to have stayed away from this type of question in more recent times, but certainly something that could be asked at Leaving Cert higher level. So we have we have an x plus root x, so x plus root x, and that's multiplied by x minus root x. So we're going to open up the brackets again, so it's x on x minus root x, plus root x on x minus root x. So multiplying it out, we have x by x is x squared. Now x times root x, they don't really join together. The simplest we can write them is by putting them beside each other, so x root x, but we can't put them under the same surd because the x isn't underneath the surd. So we can literally just write them as x root x. Similarly, root x by x is also x root x. And then if you remember in the 10 basic examples, we revised the rules of surds where we said that if you have a surd multiplied by itself, we actually end up with the variable or the number underneath that surd. So root x times minus root x is minus, first of all, plus by minus is a minus, and then root x by root x is actually just x. We can see then that the x root x and the x root x are like terms, but they end up cancelling because they have different signs. And so the final answer is x squared minus x. And again, if we were to work backwards, some people might see that this is a variation of the difference of two squares, even though it would be a bit of a leap to be able to factorize this and go straight back to the top. But again, what are we concerned with? Can we multiply out two sets of brackets and then go and apply some of the other rules in maths that hopefully we remember? The third question is taken from a Leaving Cert higher level question. We talked in the last video about a topic called differentiation differentiation, and this is from that topic as well. We are asked to differentiate this, but obviously before we can do that, we need to multiply it out. So let's multiply it out. So we have 2x plus 4 all to be squared. Maybe just to first of all do the quick way of squaring this out, and then we'll go and look at opening the brackets in a second. So we square the first, if you remember, so 2x squared is 4x squared. We square the last, 4 squared is 16, and then remember it's twice the product. So 4 times 2x is 8x, times 2 is 16x. And so that's the final answer. It only takes one line if we get good at squaring out a bracket the kind of short way. Looking at the longer method, what we would do is we would say that 2x plus 4 squared is just 2x plus 4 times another 2x plus 4. When you square something, you multiply it by itself. So opening up the brackets, we get 2x on 2x plus 4 plus 4 on 2x plus 4. 2x by 2x is 4x squared, 2x by 4 is 8x, 4 by 2x is 8x, and 4 by 4 is 16. The only like terms here are 8x and 8x, so they join to give 16x, so we have 4x squared plus 16x plus 16, which is the same answer as we got doing the quick method of squaring the bracket. And if you're going into Leaving Cert ordinary level maths, I think it's a good idea to learn that quick method. Square the first, square the last, plus twice the product. Number 4, again, as we saw in the last video, is from a topic called complex numbers. And we talked about what I was very briefly. And again, we're not going to get into it too much in this video. We're going to just treat the I as a variable, just as if it was an X or a Y or something like that. So we have 1 minus 2i on another 1 plus 2i. And opening up the first bracket, we have 1 on 1 plus 2i minus 2i on 1 plus 2i. So 1 by 1 is 1, 1 by 2i is plus 2i, minus 2i by 1 is minus 2i, and then minus 2i by plus 2i is minus 4i squared. We can see that the 2i and the minus 2i cancel, and they give you 0, and then we're left with a final answer if we were just concerned with multiplying out the brackets of 1 minus 4i squared. And again, I'd put an asterisk beside that, and if we can do that much, that's as far as we really need to know for this lesson. You may remember in the last video I said that anytime we see an I squared, that's actually the number minus 1. And so this can be tidied up to 1 minus 4 bracket minus 1. I replace the I squared with a minus 1, which is 1 minus 4 times minus 1 is plus 4, and we get a final answer of 5. Again, don't concern yourself too much with the green writing. That's called complex numbers. Deals with what's called imaginary numbers, which is a strange concept coming from the junior cert, but one you'll learn a lot about as you go into 5th year and 6th year. Example 5 is also a complex number question, but there's an increased difficulty in this one just because of the surds and the fractions. So a very tricky question to kind of jump in at if you're coming from the junior cert or TY, but for those who wanted to have a go at it, I'll run through the solution. Not one to get overstressed about, but I'm pretty sure that everybody, if they've watched the 10 basic examples and seen the 4 previous ones, would be at least able to say, I know how to split the brackets up. So there's the first bracket that has 2 terms in it, and then the second bracket also has 2 terms in it, albeit with fractions. Now, how would I split this up? Well, all I would do is I would take minus root 3, and I'd multiply that by 3 root 3 over 2, plus 3 over 2i. And remember, I is just a variable in this question. We're treating it like an x. And then I'd have the second part of the first bracket plus I, and I'd multiply that by the second bracket, 3 root 3 over 2 plus 3 over 2i. Multiplying all this out, again, we need to know the rules of surds, and we need to be comfortable multiplying fractions. You can always use your calculator, although it's obviously better to sit down and try and re-remember or relearn your rules of multiplying fractions and surds. But your calculator will do the work for you if you just want to multiply minus root 3 by 3 root 3 over 2. Root 3 by root 3 is 3, by 3 is 9 over 2, so we have minus 9 over 2. Then if we do minus root 3 by 3 over 2i, they don't really tidy up very nicely. We just have to put them together, so it's going to be 3 times the root 3 over 2i. I times 3 root 3 over 2 is just plus 3 root 3 over 2i, and then finally I times 3 over 2i is 3 over 2, and then I by I is I squared. Again, we can see that the I terms in the middle cancel. That and that are the same term, just with different signs. And we're left then with minus 9 over 2 plus 3 over 2i squared. And definitely that would be as far as we need to get to. If anyone got that far, they're obviously doing very well. We could then apply the rules of complex numbers and change the I squared into a minus 1. So that would be minus 9 over 2 plus 3 over 2 times minus 1, which would be minus 9 over 2 minus 3 over 2, which, to jump up here, is minus 12 over 2, and minus 12 over 2 is minus 6. So the green writing is the Leaving Cert higher level aspect of it, and then the black writing is a very, very, very hard version of something that you could get asked maybe at your Junior Cert higher level, although it probably is above and beyond that as well. Okay, example 6 is an example where we are multiplying 3 brackets together. So x plus 3 times x plus 1 times x minus 2. So not something we would have seen a lot at Junior Cert level. How we would do this is we would take 2 of the brackets at a time. So what we'll do is we'll section off with a bigger bracket the x plus 1 and the x minus 2. And I'm going to do everything inside that bigger red bracket first. And then when that's done, I'll multiply it by the x plus 3, which I'm just going to leave outside the red bracket for the entirety of the first few lines of the sum. So opening up what's inside the red bracket, I have x on x minus 2 plus 1 on x minus 2. So I've just opened up the first bracket, x plus 1, and multiplied it by each of the terms in the second bracket. Okay, so again, keeping the x plus 3 out in front for the first few lines of the sum. I'm going to just have a black bracket now because I'm going to get rid of these 2 inner brackets in this next bit of multiplication. So x by x is x squared, x times minus 2 is minus 2x, 1 by x is 1x, and 1 times minus 2 is minus 2. I'll tidy up that second bracket a small bit more because I can see that the minus 2x and the x are like terms and can be joined together. So minus 2x plus 1x is minus 1x. And then minus the 2 at the end. And here we can see we have a situation like some of the early examples we did on the basic questions, where I have 2 terms in the first bracket and I have 3 terms in the second. And what I'm going to have to do now is I'm going to open up the first bracket. So it'll become x on x squared minus x minus 2 plus 3 on x squared minus x minus 2. So they're a long sum, lots of opportunities to make mistakes. So it's key that you put these red brackets around 2 of the original brackets just to bracket them off first and do them. So x by x squared is x cubed, x by minus x is minus x squared, x by minus 2 is minus 2x, 3 by x squared is 3x squared, 3 by minus x is minus 3x, and 3 by minus 2 is minus 6. And then tidying it all up, x cubed is on its own, it has no like terms. Minus x squared will join with the plus 3x squared to give plus 2x squared. Minus 2x minus 3x is minus 5x, and then minus the 6. And we always like a question where they've actually given us the answer, x cubed plus 2x squared minus 5x minus 6, because we can kind of check our answer then if we didn't get what we were kind of meant to. Okay, the very last question is again taken from a Leaving Cert higher level paper. This is the 2012 Leaving Cert higher level, and it's a different type of a simultaneous equation where a couple of lines into the sum we're left with this. So this wasn't the way the question would have been written originally, but this work has to be done to progress to the next stage of the question. So let's have a look at it. So we have minus 2b minus 1 squared minus 2b minus 1 times b plus b squared. Now, what's unusual about this? Well, first of all, there's a lot of minuses in it. We generally don't see 2 minus terms within a bracket, but there's no problem there. The second bracket has a variable after the bracket. Now, that b afterwards, we treat it the very same as if it was in front of this bracket. It's still a bracket multiplied by a variable. It doesn't matter whether it comes after or before, though generally it is written before. In this sum, it came like this. Now, I'm going to multiply this first bracket the quick way. So if you've watched the other examples, you'll see that squaring a bracket, we square the first. Minus 2b squared is minus 2b by minus 2b, which is 4b squared. We square the last, minus 1 squared is plus 1. And then we multiply them, minus 2b times minus 1 is plus 2b, and we double it to give us plus 4b. If you wanted, you could come over to the side and do minus 2b minus 1 by another minus 2b minus 1, and then open up the brackets, and we would get these three terms when we had it all tidied up. So it's important to learn the quick way of squaring a bracket. Now, what do we have here? Well, we have minus and then b times minus 2b. So that's going to give us plus 2b squared. And again, it's helpful sometimes to just think of that b as being in front. Minus b times minus 2b is plus 2b squared. And then we have minus 1 times b, which is plus b. And then finally we have this b squared that was at the end of the sum. Tidying all this up, 4b squared and 2b squared, and this 1b squared, there's 7b squared altogether. 4b and 1b is 5b, and then we have plus 1. And there is a further part to this question that we won't deal with now, but you can see where the skills of multiplying out brackets is really important, and it comes up an awful lot in an awful lot of different types of Leaving Cert higher level questions. Okay, so that was tricky enough stuff. I would say that the 7 questions there are of a very high level. Hopefully if people had a go at them, they can kind of see what the link is from Junior Cert to progress into a Leaving Cert higher level standard, and hopefully the revision has helped a little. The next video is on substitution, which we've done a little bit of in this video, and we'll spend the whole next video on that topic. Okay, thanks.